Now let's look at a 3-degree glide slope. Another example or the question you get, right? We are given a glide slope of a glide path which is noted as theta of 3 degrees. Find the gradient, find the rate of descent. Just playing around with all the three again: glide slope, rate of descent, and gradient. Right? Gradient is something which you can say for a 3-degree glide slope. The gradient is
5%.
5%. Now, can you say that if you ask to derive it, how do you derive it? So let's draw a small diagram here.
So we have theta equals to 3 degrees.
That's right.
This is the gradient. So like for 1 nautical miles of distance, if we consider, so that is basically the range we can say. So let us consider that equals to 1 nautical mile.
Yes. This range is
1 nautical mile. So what should be our height? What should be our height? We need to calculate. So by the basic gradient formula, we know that it is the ratio of height to range multiplied by 100. So height we need to calculate. Range is in nautical mile. We can convert it into feet. And height also we need to calculate in feet. So percentage equals height in feet.
By
So height in feet.
Yeah. Height in feet.
Yeah. So height in feet multiplied by 100 divided by 1 nautical mile is equals to 6,000 feet by approximation we are considering.
Yeah. Yes. So it should be 6,000 feet. Yes.
Yeah.
Okay. Yeah. Now, you have to find gradient. So you already got this right. Yes, you're on track. Yeah. So what do I need now? I need height.
Height in
That is this guy. Sorry. What I would need? Sorry. It's not H here. So it's V. Right?
Yeah.
So I need this vertical, the vertical distance or height here. Yes. How do you find out that one? No. You can carry on. I'm just. Yeah. I want you to think. Think about it. So always, that's why we learn the basics than learning the equation. Always come down to the basics. What is the meaning of a 3-degree glide slope? So you told me 1 nautical mile from the threshold. What is the height for a 3-degree glide slope?
300 feet. 300 feet.
So you don't have to find out anything. This means that you have to lose 300 feet every nautical mile. So what does this be if R is 1 nautical mile? Yeah.
This is 300 feet.
That's it. How much is that?
Yeah, 5%.
That's what you got as 5% yesterday. So you got understood where you got stuck. Only thing is you're trying to find out the height, and you will not be able to find that unless you. Or see, the thing is, if you did not really come to this point, if you get a triangle like this and you have some angle here, some distance here, how will you find the distance?
Yeah, so by tan function.
Tan function, or you can use the basic 1 in 60. That is how ultimately we derive all these things.
Yes.
So you should not be getting stuck there. You can just go back and start from the basics. It's all there. Right angle triangle, this thing has to come to your mind. Ultimately, remember all these things are applications of 1 in 60 only. Right, so you got the gradient as 5%, right? Perfect. Now, what about rate of descent? You want to try this? Give it a shot again. Rate of descent, you can copy this and then you can probably try that.
We can say gradient is equals to the ratio of ROD expressed in feet per minute divided by ground speed in knots. In knots.
Okay. All right.
Yeah. So here we have the gradient of 5%, and the ROD we have to calculate, but also we don't have the ground speed.
Yeah, I don't have the ground speed here. Right. So which means in the question you have to have ground speed information because it is ground speed dependent. The rate of descent will change with your ground speed. That is why it is changing with winds. Right. So here given. We can add that. Yeah. Ground speed is 120 knots.
Yeah.
Right?
So here now I can select gradient
for a series of ground speeds because as ground speed changes. Let's start with 120 knots. right? Yes.
Okay.
What is the already? Sorry, what is the ground speed? 120.
Already.
Right? Yes. Now, what is the rate of descent?
So gradient I know is 5 is equals to ROD I need to calculate, and ground speed is given 120. So my ROD becomes 600 feet per minute.
That's it. Okay. Your rate of descent has to be 600 feet per minute. You have to lose 600 feet every minute if you want to stay on the 5% gradient or 3 degrees of glide slope. It's the same.
Glide slope.
Right? Alright. What about your ground speed is 100 knots. So one of the reasons why this could happen, as we discussed yesterday, is
Yeah.
a headwind of
20 knots.
20 knots. Right? And this one we are taking this as nil wind condition. The first one.
Yeah.
Nil wind, therefore it's more like TAS. Your TAS and ground speed is the same. Right? Here you have headwind, so it is 120 minus 20, therefore that is 100 knots. But doesn't matter. How do you find out rate of descent now? Gradient again in percentage is rate of descent by ground speed. Rate of descent in feet per minute or ground speed in knots. Therefore, what is your
Knots.
gradient? That's 5. ROD. Why is it 5? Because you are on the 3 degree glide slope.
Glide slope.
ROD by
Yeah,
what is the
fixed.
ground speed now?
Ground speed is now 100 knots.
100 knots. Therefore, what is your ROD again?
ROD is now 500 feet per minute.
So let's kind of pay attention to the step here. I'm multiplying 5 with 100. More appropriately, I'm multiplying the ground speed with the number 5 here.
5.
500 feet per minute. What happened with the headwind? What happened to your rate of descent? You have to reduce your rate of descent by 100 feet per minute. You can see there is a
Yeah.
reduction in rate of descent by 100 feet per
100
minute
feet per minute.
if you want to actually stay on this 3 degree glide slope. So I told you that before, since you have a headwind, if you keep traveling with the same 600 feet per minute, what happens is you will end up going lower and lower.
Low.
Right? And for that you have to reduce your rate of descent, because even though you are descending at 600 feet per minute here, you are not traveling the exact the same amount of distance on
Horizontal distance.
now, because now you have ground speed is lesser. By 20 knots, you are nautical miles, you are traveling lesser every hour.
Yeah.
Right? That is why you have to now reduce your rate of descent correspondingly. In this case, you can see that's what happened here. Now what if I have a tailwind of 20 knots? Or say 30 knots of tailwind. What is my ground speed now? TAS is 120 here, so it's 150. Right? 150 knots, tailwind. So without any other expressions, can I write it straight that if I have a ground speed of say 150 knots, so look at this here, I can write that rate of descent is equal to 5 into my ground speed, which is 150. Can I write it straight? Which is how much?
Yeah. It's 750 feet per minute.
So what happened here? I have
Increase.
increased my rate of descent by
150.
150 feet per minute. Why? We have seen that yesterday again. If you keep descending at 600 feet per minute, and if you have a tailwind, your descent rate is not coping up with your forward, your ground speed. You're traveling too fast forward as compared to your rate of descent, which means you have to now increase your rate of descent and get back to profile. Even from here, you have to increase and get back to profile if you want to stay on this 3 degree or 5% gradient. Make sense? Now you see a number here that we have been multiplying constantly, but multiplying with what? With
Ground speed.
ground speed. On a 3 degree glide slope, since the gradient is 5%, the rate of descent is always going to be 5 times your ground speed. So you are starting your ILS approach. So usually when you do ILS approach, you intercept your glide slope. This is your glide slope. You always intercept your glide slope from below, and that is to kind of prevent you from intercepting the false glide slope. So there are multiple lobes which forms something called as false glide slope. So to prevent you from intercepting that, you will be brought down by radar vectoring, and then they will kind of make you intercept the glide slope from underneath. Right? Once you intercept it, if you see that there is a ground speed or there is a tailwind, you see, say for example, your ground speed is 120 knots. Just multiply 5 with 5. Okay, 120 into 5. What is 5 here? That number you have to understand. That is 5 is simply the gradient. And if you are on a 3-degree glide slope, if and only if you are on a 3-degree glide slope, then you just multiply this whatever ground speed you see on your system, like 120 knots, 120 into 5 is 600. Look at your VSI, descend down, set your VSI to 600, trim the aircraft, and you will be maintaining that 600 feet per hour, that 3-degree glide slope throughout the descent, unless your wind changes. Okay, let the wind now change to 100. So the wind has now reduced, which means if I keep on descending at 600 feet, I'm going to go low. Therefore, what I'll do is I'll multiply that 100 with 5 again. 5 because I'm on a 3-degree glide slope having 5% gradient. 500, which is 100 into 5 is 500 feet. Now I'll pitch up a bit from 600 feet. I will now reduce my rate of descent to 500 feet. Remember, when you pitch up, you just pitch up, it's going to wash your speed off. You have to add a bit of power when you pitch up. That's also required. And then you again start. So basically you add power and then you pitch up. That's how it is done, right? So basically when you climb, you give power and you climb, right? When you pitch up, you give. When you descend, what happens basically? You actually descend first, or you have to reduce the power and then you actually descend, right? So that's how you do it. So basically, what I'm trying to do is, yes, so this is it. So understood what I'm trying to say here? So if you're on a 3-degree glide slope, you're lucky enough if you have the ground speed, just multiply with 5. And that is going to give you the rate of descent straight. But that is only for a 3-degree glide slope. Right? So what can I write here as a general statement? For a 3-degree glide slope, rate of descent. You can see rate of descent
is equals to 5 into ground speed.
That's it, 5 into
in knots.
Ground speed, yes, in knots. That's right. Now one more thing you see here. What made you reduce your rate of descent from 600 to 500? 20 knots of headwind.
My ground speed. Yeah.
Right? So what is the reduction in your rate of descent? Is 100 feet per minute. That will correspond to the headwind which you experienced. If you experience more headwind, you have to reduce it more. Right? What is the connection between this 20 and 100 there? That's again this guy here.
5%. 5.
Right? So if I have a 10 knots of headwind, now changing to 20 knots of headwind, by how much should I reduce my rate of descent? It's an additional 10 knots. 10 into 5, 50. Right? And I have to reduce my current rate of descent from whatever the current values, reduce it by pitch up and reduce it by 50 knots. Similarly, you see here, when I have a tailwind, what I have to do, I have to increase my rate of descent by 150 feet per minute to stay on the slope. Now this 150 is corresponding to the tailwind which you experienced of 30 knots multiplied by 5. Right? So this is one thing which you can keep in mind. When you experience a headwind or a tailwind, you have to actually increase or decrease your rate of descent by 5 times the amount by which you experience the amount of wind experience.
Headwind or tailwind.
Yeah, that is what. Now, do you have to increase or decrease? Depends upon the type of wind. If it is a headwind, you have to reduce your rate of descent.
Decrease.
If it is a tailwind, you have to increase your rate of descent. And I've told you that yesterday also. Why? Because if you don't do that, you either go low or you go high. Because now you are descending either at a faster pace or at a slower pace than the ground distance you're traveling for a 3-degree glide slope or a 5% gradient. That's the problem there.
Okay.
Right? And you have the glide slope diamond straight there in front of you, so you can actually catch up with the glide slope diamond, but and do the same thing, because basically if you're going low, your glide slope diamond is going to go up, asking you to fly up, the command instrument. But if you have this idea in mind and if you set the aircraft or that in trim, then it's a lot more easier to kind of fly the aircraft. You don't have to constantly keep doing left, right, up and down. You understand that what I'm trying to say later, but yes. So you can copy, there's so many things on board. You can just write this gradient first. If you've written this, then you can find the rate of descent for 3 different ground speeds. And if you've done that, then you can write this general statement for a 3-degree and only for a 3-degree glide slope. But for other glide slopes, you basically find out exactly in the way you found this out.
Gradient, yeah.
Yeah, that's it. And there is an equation for that also for a different glide slope, but you don't have to stuff all these things together. You can find out even otherwise.